Ons eigen melkwegstelsel neemt in het heelal maar een onbeduidende plaats in. Naar schatting bevat het heelal zo'n 50 miljard sterrenstelsels, die elk ook weer miljarden sterren bevatten. Maar hoeveel sterren we ook kennen, wat we nog steeds niet zeker weten, is of er rond één van die sterren ook planeten draaien.
If so, all of the science fiction novels that we all read might in fact have some bearing on reality. There may in fact be other beings out there who are indeed thinking about us and wondering if we're here.
If we don't find any planets, then maybe we're alone in the universe. Maybe we're very special. Maybe, certainly we're alone in this galaxy. We should take very good care of ourselves if we're alone.
Until we have a destination, there's no place to go. And looking for planets, searching the skies to see one other Earth, a small blue ball somewhere, that's what we're about. That's what we want to do.
Dit is het verhaal van een astronomische race. De winnaar is diegene die het definitieve bewijs vindt voor het bestaan van planeten buiten ons eigen zonnestelsel. Planeten bij andere sterren kunnen we niet zomaar zien. Ze staan ver weg en worden overstraald door het licht van de ster waar ze bij horen. Wat wel kan, is zoeken naar kleine schommelingen van een ster. Hoewel een planeet slechts klein is vergeleken bij een ster, oefent de massa van zo'n planeet toch kracht uit op die ster. Door een telescoop is te zien hoe de ster tijdens elke omwenteling heen en weer schommelt. En hoe groter de planeet, hoe sterker de schommeling. De astronoom Andrew Lyne vond als eerste zo'n schommeling bij een heel merkwaardig object. Een pulsar. Een pulsar is het restant van een in elkaar gestorte ster. Een bol met een doorsnede van zo'n 30 kilometer die tot 600 keer per seconde rond kan draaien. Daarbij zendt de pulsar radiostraling uit, die op aarde als extreem regelmatige pulsen wordt geregistreerd. Pulsars gelden daarom als de meest accurate klokken van het heelal. Lyne vond een schommeling in het signaal van zo'n pulsar.
But one such object, the pulses were arriving earlier and later by a few milliseconds. The natural interpretation here was that this body was moving by a couple of thousand kilometers or something like that. And it was doing it periodically. About every 6 months it moved away towards us and back again.
De schommeling die Lyne had waargenomen moest worden veroorzaakt door een planeet. Er verscheen een artikel van hem in Nature. Na de publicatie had Lyne toch nog twijfels. De omwenteling van de planeet rond de pulsar duurde exact 6 maanden. En dat was wel erg toevallig.
I was doing some more work trying to find ways in which we might be able to confirm or otherwise the hypothesis that it was a planetary body we were looking at. And for some reason I had a flash of insight as to what this might cause this. Unfortunately, my insight was correct, and I found that when appropriate correction was made, 6 month periodicity disappeared, and of course so did the planet.
De schommeling die Lyne had gevonden was niet die van een andere planeet, maar van de aarde. Door een computerfout waren de berekeningen niet voor de aardschommeling gecorrigeerd. Toen Lyne dat zelf deed, verdween de schommeling.
I had to let everyone know as soon as possible so that they would not dwell on an object which did not exist and would not tax their ingenuity for understanding it.
Een paar weken later kon hij het trieste nieuws brengen op een bijeenkomst in Amerika, waar planeetspeurders kwamen luisteren naar de man die hen te snel was afgeweest.
I was in this room with 500 astronomers, very excited. Here was a guy who was going to announce the discovery of a planet around a pulsar. And we expected to hear the technical details of that and share in his triumph, because we're all in this game together. And he stood up there and he listed 3 things that this signal could be, and the last of them was a mistake. And he said, unfortunately, it's the last of those reasons. And I went, and 500 people in the audience went,
This poor scientist had to get up there and tell the world that he had been wrong, and publicly wrong. And I felt very proud, frankly, to be a member of a group in which, in the end, honesty was the most important thing.
Andrew Lyne's example was a terrific object lesson, that you've got to be absolutely sure. You can make a living at a certain level saying maybe for a long time, but if you're going to say absolutely yes, you'd better be absolutely sure.
Lyne kreeg een staande ovatie. Maar de pulsarplaneten bleven onderwerp van gesprek. De volgende spreker was Alex Wolsjan, die ook een pulsar had waargenomen die een schommeling vertoonde.
I found it much more challenging and less relaxing than it would be, simply because certain atmosphere was set after what Andrew had said. Certain climate around the whole story, and I had to break through this.
Het leek of de schommeling niet werd veroorzaakt door maar 1 planeet, maar door het gezamenlijke effect van 3 verschillende planeten die om de pulsar heen draaiden. Juist door de invloed die ze op elkaars baan hadden, werd de aanwezigheid van deze planeten uiteindelijk aangetoond.
Very, very fortunately, the planets sort of meet together once every 200 days. They get very close to each other and interact gravitationally stronger than in any other situation.
Bij elk treffen veroorzaken de 2 grootste planeten afwijkingen in elkaars banen. Daarvoor vond Wolsjan bewijs in de schommeling van de pulsar. En als het inderdaad planeten waren, moest hij die afwijkingen kunnen voorspellen.
The very nice thing about this is that it's just celestial mechanics. It's Newtonian mechanics. So you can build the model of perturbations, and it has to work exactly. There's really no way out of it. It either does work and it's planets, or it doesn't and it must be something else.
De afwijkingen waren precies zoals voorspeld. En Wolsjan wist zeker dat hij een planetenstelsel had gevonden. Maar niet iedereen stond te juichen.
Pulsar planets really don't move me emotionally. The reason, of course, is that ultimately the big payoff in this game is to find a harbor for life. And we all know that life can't form around those so-called pulsar planets. The environment is far too harsh with X-rays and radio waves beaming onto the planet. And so for those reasons, it's almost certainly the case that such a planet doesn't yield the possibility of the real excitement, namely intelligent life.
If we want to be optimistic about it, and I think we have every reason to be optimistic, then the message simply is there are many more planets to find around all kinds of stars. If you can make planets in such a strange and maybe even hostile environment as the environment of a rotating neutron star, the product of a supernova explosion, a dead star, if you want to use really big and dramatic words, then what's wrong with making planets around such nice and quiet stars like our sun?
Voor de planeetspeurders waren de pulsarplaneten een mentale oppepper. Maar toch bleven ze zoeken naar een planetenstelsel als het onze. En Jeff Marcy was één van de speurders in deze planetaire race.
We select stars that are more or less like the sun, bright enough, close enough to be examined carefully with an optical telescope. And the problem is that there are literally thousands of stars that are more or less like the sun. Fortunately, they're all cataloged in this world-renowned source of information called the Bright Star Catalog. And so we actually looked through all of the thousands of stars in this catalog that I've been using now for years, and we selected out those stars which are solar-like. I think since it's clear, we should do the faint stars.
Alle planeetspeurders hebben een lijstje met te observeren sterren. Als ze een fout maken of iets over het hoofd zien, verliezen ze de wedloop. Er moeten knopen worden doorgehakt. En dat deed Jeff Marcy ook.
One of those stars is called 51 Pegasus, and we rejected it from our sample because in this particular 1982 edition, 51 Peg is classified as a G2 subgiant star, meaning it's an old evolved star. Old stars begin to puff out, and their atmospheres become frothy and gurgly, much like a pot of boiling water. And when an atmosphere is gurgling like that, there are Doppler shifts. The light is suffering Doppler shifts due to these motions, and it obscures the signal from the planet. And therefore we rejected it. We threw it out of the sample.
Een ongelukkige beslissing, want er was helaas een fout gemaakt met 51 Pegasi. In latere catalogie werd de ster correct geclassificeerd als een identiek tweelingzusje van onze zon. Daarmee was 51 Pegasi een ideaal object voor de planeetspeurders. In Frankrijk hadden 2 Zwitserse astronomen hun eigen speurtocht op touw gezet. Ze hadden 140 sterren op hun lijstje staan, waaronder 51 Pegasi. Maar ze konden veel sneller gegevens verzamelen dan Jeff Marcy.
The most important difference between Jeff and our own technique is mostly the reduction process, is the way to extract the information of the huge quantity of data we are measuring with the spectrograph, and we have the possibility to have immediately the velocity in the dome.
We have a black box, and with this black box we compute right after the observation the speed of the star, let's say 10 minutes after. And that's very original compared to Jeff Marcy. And that's a key point because as you have your result right after the observation, you can interact very rapidly with your data. And for example, observe the same star the day after if something is special or strange.
En 51 Pegasi was een bijzondere ster. Hij zag er op het eerste gezicht heel gewoon uit. Maar na een paar maanden merkte het Zwitserse team iets vreemds op. Uit de computerberekeningen van Didier Queloz bleek dat er veranderingen optraden in de snelheid van 51 Pegasi.
In fact, the first reaction that you have at that time is, oh, something is wrong with the experiment. You never think about planets. And you observe it again the day after and the day after. And then it was more and more awful because it was moving every day. And you say, all right, there is really a big problem with the experiment.
51 Pegasi was dus op hol geslagen. Maand in, maand uit reden Major en Queloz van Genève naar de sterrenwacht in Frankrijk en zetten de snelheid van de ster uit in een grafiek. Bij elke waarneming was de snelheid veranderd. Na een aantal bezoeken aan de sterrenwacht viel er een patroon in te ontdekken. En de uiteindelijke grafiek gaf een duidelijke schommeling te zien. In maart 1995 dachten ze alle bewegingen van 51 Pegasi te kunnen voorspellen. Maar toen ze dat wilden gaan testen, stuitten ze op een probleem.
And then as the sky is moving, you cannot observe the same star during all the year. And then the star we could not observe that stars after March. And we had to wait up to July. And then we had the curve, the wobble. We had a prediction, but we had to wait.
In juli gingen de Zwitsers terug, gewapend met hun voorspelling. De eerste nacht was de meting aan 51 Pegasi precies volgens verwachting. De tweede nacht eveneens. En aan het eind van de week hadden ze bewijs te over. Ze brachten het grote nieuws op een congres in Florence naar buiten.
The first reaction was enthusiastic, because at that time people thought that it was too difficult to find planets. And then we bring this news and we say, we can find them. And then people say, all right, that's nice, we can find them, then we have to try. Yes, it was enthusiastic.
In fact, it was a completely crazy time with call from papers, from television, from radio, from all the world, and email, 100 emails per day or something like this. It was absolutely a completely time where we have no possibility to work at all.
Well, to be honest, when I first heard about 51 Peg, I thought, oh no, here we go again, another false detection. I'm going to have to spend another few months of my life debunking yet another planet, and I've debunked quite a few. Some of my friends, in fact, call me Dr. Death because of all the planets I've debunked. And I thought to myself, this is just going to be another headache. And at first, I realized that the only way to debunk was to start taking data. Yeah, there it is. Looks beautiful.
Marcy richtte zijn telescoop ook op 51 Pegasi en kwam tot zijn verrassing tot dezelfde conclusie. De Zwitsers hadden hem werkelijk verslagen. 51 Pegasi schommelde en wel met een gigantische snelheid van 4 dagen.
If the periodicity of the wobble is only 4 days, that this corresponds to a rotation of the planet around the star of only 4 days. So, and this for a planet is completely unusual. The shortest period in our solar system is Mercury with 80 days. So this corresponds to a planet orbiting extremely close to the surface of 51 Peg.
This planet defies all of our expectations about the locations of Jupiter-like planets. The broad consensus now is that we're left with a planet probably between a half of a Jupiter mass to 2 Jupiter masses, orbiting 1/20th of the Earth-Sun distance from the star. And there's almost no question that this thing is best described as a planet. The question is, how did it get there?
Niemand gelooft dat de planeet zich in de enorme hitte dicht bij 51 Pegasi heeft gevormd. De planeet heeft zich vermoedelijk verder weg ontwikkeld en is toen naar de ster toegetrokken, onderwijl materie rond de jonge ster opslokkend. Daarna bleef de planeet in een baan dicht om de ster heen draaien.
Well, I think the planet around 51 Peg is a great step forward. Certainly it'll go down in history as the first planet ever found around a normal star. But it doesn't quite hit home for me because it's not like any of the planets in our own solar system. And so the question still remains, after all of this, do we find among other solar-type stars planets that are like the Earth, like our own Jupiter? And that question has not yet been answered.
2 weken later kwamen honderden Amerikaanse astronomen bij elkaar om over hun vorderingen te praten.
On a guide star, you correct for the atmosphere, and then you integrate for a very long time.
And she said, oh, use 48. So I did. You know, she's the expert.
Yeah, it's not so bad because it's in C North B.
In de astronomie is dit een spraakmakend congres. En al snel ging in de wandelgangen het gerucht dat er een belangrijke onthulling zou worden gedaan.
Dr. Jeffrey Marcy from San Francisco State University.
Today, I would like to announce here, for the first time, the definitive discovery of 2 new planets around 2 other stars. Well, it's a wonderful discovery, I think, for me, but really much more so for science, astronomy, and really, I think, everybody. The first is the star 47 Ursa Majoris in the Big Dipper.
Aangemoedigd door de ontdekking van 51 Pegasi had Marcy zijn eigen gegevens doorgespit. Op de harde schijf van zijn computer vond hij nu allerlei bewijzen voor een aantal planeten.
And finally, I'd like to show you another planet that we feel even more strongly about. What's fantastic about this planet is that it is in close enough, but not so close at this Mercury-Venus distance, that the planet's surface will be warmed up to a temperature that is, well, almost comfortable for all of us. And in fact, here are... Yeah, well, the really exciting planet, I think, is the one that's around the star 70 Virginis. The planet is about 80 degrees centigrade, which is about the temperature of warm tea. And it means that water would not be in steam form or ice form, but instead water would be in liquid form. Liquid water, maybe droplets, maybe lakes, maybe oceans. And it means that maybe this planet would be a suitable site for organic chemistry to take place, maybe eventually forming the building blocks of life.
In een aantal maanden zijn er nu zo'n 10 nieuwe planeten buiten ons zonnestelsel ontdekt. Maar de bewijzen voor hun bestaan zijn slechts indirect. De pulsarplaneet, de reuzenplaneet bij 51 Pegasi en de meest recente ontdekkingen zijn nooit werkelijk waargenomen. Met de huidige techniek kunnen we alleen de schommeling nog maar zien die ze teweeg brengen. Maar de mogelijkheid om planeten rechtstreeks waar te nemen ligt binnen ons bereik. De belangstelling voor de Planeetspeurtocht is enorm toegenomen. En ook de NASA gaat zich er nu mee bezighouden.
Could you imagine if in 25, 30 or 40 years we could take a picture of a planet that's perhaps 50 light years from Earth? And if that planet had, and if the resolution was high enough to measure, to take a picture of oceans and clouds and continents and mountain ranges? Breathtaking! Breathtaking.
In de nabije toekomst is zo'n groots portret van een vreemde aarde misschien nog niet haalbaar. Er zou een telescoop voor nodig zijn, zo groot als de maan. Maar uiteindelijk willen we toch een direct bewijs voor andere levende planeten.
I'm not constraining the scientific thought, and I'm not even promising that we could do it. But there are a lot of people now that are beginning to say, hey, I have some ideas.
Well, there is just a glorious prospect if we can actually detect a planet itself, because then we can take the planet's light, shove it through one of our spectrometers, and analyze that light for the presence of chemicals, the chemicals of life, such as oxygen, methane, and most importantly, actually, water. The neat thing about detecting methane and oxygen in a planet's atmosphere is that we know that those two chemicals react with each other almost instantly. So if you find both oxygen and methane in a planet's atmosphere, you know that those two chemicals must be in the process of being produced, literally every minute, every month. And obviously, one strong possibility for the production of those chemicals is life itself.
It is so exciting thinking about the possibility of life elsewhere. We are on the threshold of a new age, and I think in 25 or 30 years, when my grandson has children, and those children are in kindergarten, there's a high probability there'll be a picture on the wall of a planet with oceans and continents, and mountains, and clouds. And those children will look at that picture, and then they'll look up at the sky. I think we could do it. We're not afraid.
A name for the planet.
Difficult question. I cannot answer.
Until I was really sure that it was a planet, I wouldn't entertain such thoughts.
I'm not ready to name them. A, B, and C. That suits me quite all right.
If I had the choice, I would probably name it after my daughter, Kaylee. Kaylee's World.
We've got a name for one of them.
Probably Vulcan.
We decided to call it the Goldilocks planet because that planet has a temperature that is just right.
My kids came up with the best one. They know I'm looking for planets. Said, Dad, name it Planet Reebok. Make some money off of it.
Willkommen bei Space Watch. zu einem ganz besonderen Ereignis, dem Vorbeiflug des wohl größten Kometen unseres Jahrhunderts, Hale-Bopp. Die vielen Fernrohre auf der Erde und das Weltraumteleskop Hubble hier im Orbit werden uns spektakuläre Bilder dieses Schweifsterns